Hello everyone, this is Jesse Crawford with New York Medical College, and this is the lecture video for summary statistics. This first slide shows the basic framework of statistics. Let's say you're interested in figuring out what the average age of people in New York is. Another word for average is mean, so we're trying to find the mean age of people in New York. One way to do that would be to talk to every single person in New York, ask them what their age is, and then calculate the average of those ages. The problem with doing that is it would actually be prohibitively time-consuming and expensive. You would have to travel to everyone's house, try to find them, interview them. They may not be home, or you could try to call people, but not everyone would have a phone necessarily. So it would take a lot of time and resources to do that. So what we usually do in statistics is we take what's called a sample. A sample is a subset of the population, and it has the advantage that it's small enough that we can actually obtain all the data we need, and then we can calculate the sample mean using that data and use the sample mean as an estimate for the population mean. Ideally, you would want to select a sample from your population randomly because that can help you to get a representative sample. All of these ideas are represented in the diagram on this slide. The circle on the left is the population, which is everyone in New York, and the circle on the right is the sample, which is just some subset of the people in New York. Now, the population has a mean, which is called the population mean. That's represented by a Greek letter mu. A Greek letter mu is like an M, so that's why it stands for the mean. Then the sample also has a mean, which is called the sample mean, and that's represented by x bar. There's an arrow from the left to the right which says sampling, which just represents the idea that in order to get a sample, we select it from the population. And then there's an arrow from the right to the left called estimation, and this refers to the fact that we use the sample mean in order to estimate the value of the population mean. This is an important idea because, again, we can't actually calculate the population mean directly. We're not going to be able to talk to every single person in New York. So we take a sample from the population, we calculate the sample mean in that sample, and then we use that value to estimate the value for the population. A couple other terms that are present on this slide are the ideas of parameters and statistics. Parameters are any numbers that are related to the population. So in this case, the population mean, the actual average age of everyone in New York. That's a parameter. Whereas a statistic is some value that's related to the sample, in this case, the sample mean. So the average age of the people in our sample is a statistic. This slide just emphasizes that idea that parameters are values that are related to the population and statistics are values related to the sample. Here's a quick example. Let's say you're interested in estimating the percentage of adults in the United States who are obese. As we discussed a moment ago, you wouldn't actually be able to measure whether every single person in the United States is obese or not. So we could take a sample, 100 adults from the United States. Let's say in that sample, 30 were obese and 70 were not. Then we would simply say that since 30 out of 100 were obese, that's 30%, and then we would use that percentage as an estimate for the percentage of people who are obese in the population. A moment ago, we were talking about calculating the average age or mean age of people in a sample, and this slide goes through an example of such a calculation. Let's say you had 9 children whose ages are given on the slide from 4 to 16, and you wanted to calculate the mean of these numbers. Now, the mean is just the average, and we're all familiar with how to calculate an average. We just have to add up all these numbers and divide by how many numbers we have. We have 9 numbers in this sample, so we add up all the numbers, and that will actually give you 90. And then we divide by 9 because there's 9 numbers in this list, and 90 divided by 9 is 10, and so the average age of the children in this sample is equal to 10. Below the calculation, we can see a mathematical formula for calculating the sample mean. Let's run through this formula and talk about what all the symbols represent. On the far left-hand side, we have x bar, which is just the symbol that we use to represent the sample mean. And on the right-hand side of the equation, we start off with 1 over n. Now, n is the sample size. It's the number of elements in the data set. For example, in this problem, there are 9 children in our data set, and so n is equal to 9. And then the next 2 symbols are summation xi. So that capital Greek letter sigma stands for summation, and the word summation just means add everything up. So summation xi literally means add all the numbers up in your data set. So we can see that this formula actually just represents what we did above. It says the sample mean x bar is equal to 1 over n, in other words 1 over 9, times the summation of everything in our data set. And the summation of everything in our data set was 90. So it says x bar is equal to 1 over 9 times 90, which is equal to 10. There's no difference between taking 1 over 9 times 90 and dividing 90 by 9. Those are the same thing. So this mathematical formula really does represent how to calculate the sample mean. This slide talks about the concepts of minimum and maximum. And the minimum of a data set is just the smallest number in that data set, and the maximum of a data set is the largest number. So for example, sample 1 here has a minimum equal to 4 and a maximum equal to 16. And sample 2 has a minimum equal to 1 and a maximum equal to 19. Another thing that's kind of interesting about this example is the mean for both of these samples is equal to 10. We can just check using the method we saw in the previous slide that if we add up either one of these samples, we're going to get 90, and then we're going to take 90 divided by 9, and that's going to give us 10. So this example shows that even if two samples have the same mean, it's actually possible that the min and maxes are different. We've already talked about how to calculate the average of a bunch of numbers, but you also want to be able to talk about how much spread there is in a data set. And one way to calculate the spread is using the range. The range is a simple idea. It's simply the difference between the minimum and maximum values. So you're going to take the maximum value in this case, which is 16, and subtract the minimum value, which in this case is 4. 16 minus 4 is 12, so the range is 12.